am. Yes. Hello. Awesome. Okay. Yeah. Thanks everyone so much. And today we'll be talking about some of the challenges that I've been facing at a sort of new startup called NumberStation. Really with actually taking these large language models and deploying them on structured data tasks. And I'm going to talk a little bit about a suite of models that we've released to kind of address some of these issues. So I know we've all kind of been in this space for a long time. I want to spend a minute or two just kind of recapping a little bit on how we got here, partially because it really motivates how these things are sort of lining up and what the challenges are for deploying these models on production workflows. So again, as we're all have heard, I'm sure many times by now, foundation models at the core are just very, very large neural networks trained over massive amounts of data with self-supervised learning. And the key thing here with self-supervision is that you can train on data that doesn't need any manual engineer labels to go and train, right? You can train on data that kind of exists naturally on the web. The classic example is the language modeling task, where you literally are shoving words at the model and asking it to regurgitate, the words next up in the sentence. Next token prediction task for the most part. And what this really opened up is the ability for us to scale our data to very large sizes, because again, we didn't have to go get it manually labeled. So I could point to an entire, from the last talk, web crawl dump, even PDFs, and train a model over that. Now, what we saw since around 2018-ish era is also a massive increase in the size that we're able to train on. This was both due to algorithmic improvements as well as hardware improvements. And so what you see here is a massive increase in the amount of data that we're training on and the size of the models that we're training on. And what resulted was this kind of OpenAI, these GPT models, and their ability to kind of have in-context learning, which is really what's kind of breaking open kind of the application building space. And at the core, what this means is that you have one model that can do a wide variety of tasks without any fine-tuning, without any training, just by changing that kind of input text that you're getting it. Again, these models are black box text generators, right? You give it text, it'll spit out more. And so what this means is that by carefully kind of crafting prompts and inputs to these models, they can do different tasks for you, right? So here are some very sort of simple examples of doing capital prediction, as well as maybe something more in the structured data space of like cleaning your data, reformatting dates. You can give it a couple examples, a description of what you want to do, and the models can go and perform this task for you. Now, not only was this kind of just absolutely astounding that this worked, but this really changed the game for how we were building applications. And there's really three things that I want to focus on for this talk. Obviously, it's with all the startups popping up around this, there's a lot of benefits to these models. But some of the three really important ones I think are this notion around tasklessness. Before foundation models, even in the deep learning days with BERT models and embedding based models, you had fairly siloed pipelines. And by that, I mean, you'd have a set of data, a model, and a task, and you'd have kind of one model per task. And that meant that every model had to be maintained, the data had to be curated, you have MLOps deployment, kind of all those challenges, have to be addressed as well. But with these foundation models, you have one model that sometimes you don't even have to host, depending on how you use the model. And so it just makes for much more simpler pipelines that are much easier to maintain over time. So this another huge benefit here is this notion of solving the cold start problem. Again, these models don't need any data to train. I can go and prototype a task and build a demo in a day, which used to take months of effort to go and sort of get a proof of concept that something could work. And so it really, all this kind of vast knowledge of how to do tasks and how to different kind of information is already latently in these models. And so you can take advantage of that very quickly, again, without having to go have that upfront cost of labeling data. And this last bit is the notion of democratizing access, right? You could argue that these models are coded via natural language, right? I don't have to go and know how to program to go and test out a task, actually, for the most part, build an application now. So you see a much wider variety of people who are able to go access these models and take advantage of them. And this notion of natural language programming is just a very powerful paradigm to allow more people access to build off these models. So the startup that I work at is called NumberStation. And we're kind of coming out of the Stanford AI labs, and we're really trying to apply language models to the modern data stack. And then, at a very high level, and this is kind of a very, very simplified pipeline of kind of what the data stack looks like. Starting out with your raw data sources, your integration layer, then eventually move up to transformation layers, lastly to the business intelligence and kind of data analytics space. And so this pipeline can be super complicated, messy. There's communication hurdles between all the different stacks. And at the very high level, Numberstation is trying to use foundation technology kind of at the top of the stack to help sort of simplify and make this process faster and allow users to gain insights to their data more quickly. And in particular, what I want to, the kind of core product that I want to focus on in this talk is this notion of data analytics, that kind of last layer of that data stack, which is business users, business analysts trying to understand and gain insights into their data and, for lack of a better word, take action on what they want to do. So how this pipeline works typically or traditionally, which is kind of shown on the left here, is usually a business analyst has a question or maybe a set of questions. They want to see some dashboards, but they don't actually have any understanding of what's in their data. They don't know the schema. They don't know SQL. They don't know how to access any of this. So typically it involves round-trip communication with data engineering teams, sometimes even Tableau teams, to go and to generate that insight for them. And this process, while it works, can take weeks and even sometimes in the extreme case, months for this business analyst to get an answer to their question. And so the high-level insight is that with these models, again, they're programmed to be a natural language, which means theoretically, a business analyst could just ask their question on a foundation model, and the model could go and actually generate, in this case, like a SQL expression, for example, to go and execute and get that result back, right? So the idea is with foundation models, we can go and allow business analysts to gain these insights with, almost in a self-service manner without having to go and spend a lot of time, round tripping with data engineering teams to be able to get access to their data. So in theory, and you can go, there's tons of tweets and videos showing that these models can do these tasks like text to SQL. So there's a lot of promise that thinking that, hey, look, there's something to build here and something that can be very useful to the modern data stack. But one of my favorite phrases with these models is that it's building a prototype, building a demo with a foundation model is very easy and very fun. Actually getting them into production is much more difficult. And in particular, I'm going to walk through, three kind of core challenges that I've been dealing with a lot in the last year around what it takes and some of the difficulties with actually, again, taking this kind of nice little prototype idea and putting it into production. And so the first one that you run into pretty much immediately when you're dealing with real kind of enterprise workloads is these models are not customized, right? They're kind of jack of all trades, but they don't really understand the enterprise's any sort of specific company's data or idiosyncratic language or how users talk about the question. And so this is an example motivated from workloads that I've been dealing with is assume you have a table that's looking at sort of property data. So you have a property, maybe the city, some attribute that's called num WKO and an attribute called neutral. And in real enterprise data, you get columns that are named things that don't make any sense to you, but there is a subset of data engineers who understand the semantics of that column. And so the user wants to know what properties have a satisfaction score greater than 75%, right? They're asking from a business analytics perspective of this is what I want to know. Now, the model, if you give this to ChatGPT or kind of almost any model, it'll make a guess, and maybe it'll give you some query that's looking at maybe the neutral being greater than 75 or something like that. And it turns out that this is not a correct query at all, because the notion of what satisfaction score isn't available to the model. It doesn't know. It was never trained on that. It's certainly not clear from the data. You have to go and actually get that insight from the data engineers who say, oh, satisfaction score is defined, this metric is defined as, the number of work orders divided by neutral, for example. And so the correct query actually has this kind of business logic around what it means to have a satisfaction score. And without sort of customization or understanding how to teach the models how to be customized to an enterprise, they're not going to be able to really handle these business analytic questions because they just don't know the answers to how business users talk about their data for a specific enterprise. So the second challenge here actually comes with the fact that some of these models you're lacking SQL expertise that are really needed to address business users' questions. Going back to what I mentioned earlier, these models are kind of jack of all trades. They've been trained over numerous languages. They are incredibly powerful. But when it comes to some really advanced SQL queries, especially if you're looking at maybe open source models, and trying to move away from some of the private ones, they really kind of fall flat when it comes to some of these kind of nuanced SQL queries, especially with how users can ask for them. So, for example, if you're the users again going after this property data, asking for some difference in scores compared to the average of each city, a model again will give you something seemingly correct, but it's missing some of this kind of partitioning, nested logic that can be pretty tricky for it, right? They're not expert SQL editors and don't have, again, the SQL experts' knowledge about really how to generate SQL. So you also run into just purely quality issues where even if it was able to kind of get the business logic correct, it doesn't always get the SQL correct. And now the last challenge is really addressed, and I kind of hinted at this earlier, with the fact that enterprises need privacy, right? And a lot of the models, a lot of what you see today are being built off of third-party models. Third parties that are going outside of the enterprise's VPN, their kind of private network. And so oftentimes, even if they wanted to engage with this technology, they simply can't. They don't want their data, and especially their data schema, so even their business questions, leaving their company. And so they really need to be able to host models that are can be hosted locally within their network. And you're seeing, companies trying to help address the situation. But really, it's been a bottleneck to sometimes getting some of these tools deployed in production is the fact that they don't want to use these third-party models behind API walls. Okay, so I just kind of quickly went over these three challenges around customization, quality, and kind of this notion of local hosting. And so now I want to talk about, a bit about what we did at NumberStation to start to address this problem, and really lean into the fact that we want the open source community to have access to models, not only that can be used for enterprise use cases, but also for academic use cases for anybody. And so this is what we ended up doing, again, to take a first step here, is actually to go and say, hey, look, let's actually build some models ourselves that are good at this sort of SQL generation, at text to SQL task. And then we're going to release them and sort of help them be open source and release a whole suite of models that can be used by anybody. And so we went and did that. So we have about 4 NSQL models. I'm now going to start to kind of now it's explain how they're really helping us address some of the challenges I mentioned in the last couple slides. So the first one is that these models are fully open source for academic and commercial use. And so this notion of being unable to the models that lack personalization, you now have an option for personalizing them. Now, I'm not solving this issue per se, but at least there's an ability that I can go, and one of the natural cases that have been talked about in this sort of event already is this idea of fine-tuning over your own data. And now these models are open source and available. Users can go and take the models and start to customize them so they can start to understand that business logic and how users ask questions, right? So it's opening the door for these models to be personalized to really address that customization issue that I mentioned earlier about kind of some of these third-party or sort of general purpose models. So the next one is this idea of lack of SQL expertise. And for us, and I'll explain in a couple slides, these models were trained heavily over sort of heavily curated text to SQL data. And so the idea is that these models are actually somewhat of SQL experts themselves. There's obviously still work to do, but they've been really focused on SQL. They don't know Python. They don't know other coding languages. They lost some of the generality of these big models, but are kind of becoming nuanced SQL experts. And so with one of our versions of the model, you can actually start to get some of this nested, more tricky SQL logic that these models can understand how to do because we've, again, focused them on SQL, right? So we don't want them to be these general models anymore, but they're heavily focused on SQL. And so here we're dealing with some of the quality issues that we saw earlier with some of these open source models not really having the SQL capabilities. Now, this last challenge I mentioned was really around the fact that enterprises couldn't always rely on third-party models, really wanted to be hosting something on-prem. Well, and so one of the things that we did to really try to address this challenge is not just release one model, but to release a whole suite of models at different sizes. And the idea here was to really make it easy for enterprises to kind of satisfy their own hardware constraints and their own latency constraints for their business, so that they can kind of again flexibly handle the trade off themselves of what quality that they wanted versus the difficulty of hosting it and again the speed. Generally speaking, bigger models are slower and more expensive to host. But if you provide them a different kind of set of sizes, again, enterprises have some flexibility in what they can do there. And so the hope here was that together these models allow for enterprises to really address issues around quality. They can now customize the models, and again, they can now host them locally, so they don't have to again be accessing third parties. So I'm going to spend the last 4 minutes talking a little bit on how we did it, and then going into a couple high level results here. So at a high level, when it came to building these NSQL models, it was really this two-step approach and all focused on the data, right? As the last speaker said, which is so true, garbage in, garbage out. And so the data curation bit was 90% of the effort. And so what we ended up doing was actually having kind of a two-phase training approach. And the first is this notion of sort of focusing the model on SQL. We went and we scraped a bunch of SQL queries just from the web, from open source repositories, and just, for lack of a better word, shoved raw SQL at the model and did sort of the simple next token prediction task with the hope that it would start to learn kind of keywords like SQL keywords, SQL query patterns, a little bit around comments. And so you got this pre-training phase over SQL. And then the second step was this heavily curated data set we constructed, which has about 300,000 pairs of instructions, schemas, and then the output SQL. So it's basically a very curated set of text to SQL data that is teaching the model how to follow user instructions and actually spit out the correct SQL. So after you pre-train the model, you kind of have this fine-tuning, instruction tuning phase over text to SQL, and then the result is the NSQL model suite. And so the text to SQL data also, if folks are curious, it's also openly available on Hugging Face, so please take a look. All of the sources that we use were open source data, so all available on the web. We did a couple tricks around augmentations and getting some of the questions weekly labeled, but for the most part, they were, again, everything was just a lot of scraping and cleaning on our part. So again, please take a look if folks are curious. So at a very high level, I just want to briefly touch upon how these models are kind of addressing some of these quality issues and starting to close the gap with these private models in terms of text to SQL capabilities. And so we have 4 models. 3 of them are based on the Cogid model from Salesforce, which they do an incredible job with their models, and then also the very recent Llama 2 model. And so again, we have these 4 models. And so what you start to see is that immediately, especially once you're moving into the multi-billion parameter model, the NSQL models are kind of outperforming available open source foundation models when it comes to text to SQL, even ones that have been trained specifically on code. And this is looking at a very standard academic text to SQL benchmark called Spider. And in particular, you see the Llama model, which is following the recent trend and outperforms the rest. And what you also see, which is very exciting, is that they're starting to also close the gap with proprietary third-party models. And in particular, on this benchmark, some of the Llama version is competitive and on matches performance with the GPT-4 model released by OpenAI. So you do start to see that if you're focusing the model and sort of specializing on a task, not only can you get away with a smaller model, it's only around 7 billion parameters, but you're also able to match performance with these very large proprietary models. And in part because the proprietary OpenAI ones have to be very general purpose. They have to address a bunch of challenges, whereas, in this case, you can just focus on SQL and match performance. Now, the last little kind of interesting thing to hint at is that all of this training, that kind of two-step approach, is actually really important to turn on quality. What you see in the light purple is like the base model performance. The sort of middle bar is saying, hey, look, just after pre-training, we're starting to see lift, right? It's already starting to understand SQL. And then really that last little instruction tuning is kind of what turns on performance, because it's learning how to pay attention to how a user asks. So to say that all of the training, again, the more data, the more high quality data, the better. And you do start to see kind of a consistent trend depending for both phases of training. So that's pretty much all I have, is sort of, again, talking about what it takes to deploy these models in production. challenges around the customization and the quality, and be able to host them privately. And how at Number Station, we went and actually built a bunch of models and released them on the open, to let users go train, customize, and host them themselves. So do not hesitate to reach out with any questions. Links to the models and the data are all on the slide. And we also have some blog posts if folks are curious. So thank you so much, and I'm happy to answer any questions.
Thank you very much, Laurel. This was absolutely fascinating. We already have a couple of questions up on Gradual. And this is already something that I was thinking about too. If you can move back to the slide where you guys were, well, at least you mentioned cleaning the data. So one of the issues that you had was that I was thinking about, well, how did you even come up with the language to SQL pairs in the first place? And then you said, well, you went and you scraped it all, but then you had to subject it to a relatively rigorous pipeline of cleaning. What did that cleaning look like? And did you manage to do this in an automated way? How opinionated is the cleaning process? Yeah, I think it was this one.
Yeah. No, that's a great that's a great question. And we a lot of it was taken. So usually we start out with there's a ton, especially if you're kind of tricky with how you search for these things, a ton of open source kind of academic benchmarks that look at text to dashboards, text to SQL, text to data. Like there's a lot of text to XYZ. And so a lot of it was us kind of curating and figuring that out. And a lot of cleaning was around simply making sure the SQL is executable, making sure the schema matched the SQL. Oftentimes you'd have mismatches across, data was just messy in that sense. You had to have it kind of be answerable. And so a lot of this, although it took time, was all automatable once you kind of understood how to use a SQL parser and how to kind of do checks and make sure things were runnable. The most interesting piece to me is that actually what we ended up doing is sometimes we'd get high quality SQL and schemas, but the questions were garbage, right? The questions either didn't make sense. And a lot of this was just us manually looking at errors. And so we see entire data sources where the questions just couldn't be trusted. And so in that case, what we'd actually do is use other open source models. I can't remember which one we used. Maybe have to use Llama for this. We actually used open source models to help us label the data. So we'd start with the SQL, and we'd have the models generate text for us. SQL is the whole problem is that going in the forward direction is hard. It's hard to have models really output good SQL. They're really good at explaining SQL if you give it to them. And so you could actually leverage open source models to label a bunch of data. So that was another thing we did. And then also there's a couple of tricks you can do just with augmentations where you can go and expand your test set or training set by kind of swapping out different order by clauses or changing up different things in the group by, little things like that, where you can kind of make deterministic tweaks to the query, and then again, go get the question relabeled. So at the core, it was a lot of parsing and a lot of sort of schema sanity checking, and then again, using models to go label data for you, which is a very interesting paradigm.
Yeah, so then you must have also then used, okay, so perhaps this is what you're saying. You were also using models to then classify the quality of the question too. So how would you know if you have 290,000 samples to have people come in and just sanitize or clean or even throw away or discard bad text? Would you have a separate model that kind of classifies the badness or goodness of that text?
You could. We didn't. Again, we kind of just looked. There were 20 sources, so in this case there was a little manual of us just looking at each source and making sure that we thought the quality was good enough. Now, certainly not everything's perfect. The other idea is that if you get enough data, you can handle a bit more noise. So the smaller the data set, the more curated it needs to be. So yeah, we kind of knew beforehand whether or not the source needed to be relabeled. But you could imagine using more. I don't know if I would have relied on a model to tell me yes or no, but you certainly could have done things around, hey, look, if I send this question to 10 different models and they all give me wildly different answers, it's probably not a good question. It's too vague, it's too ambiguous. So there are a lot of things you can do that take advantage of the fact that these models are noisy to actually understand how trustworthy the question is.
We have a few more questions here. I'll try to serve them in a rapid fire sort of way.
Okay, great.
What flavors of SQL, ANSI, Transact, does this work with?
Yeah, so right now just SQLite, but we're actually actively working on adapting it to a couple other dialects. That's not too bad. You can kind of use existing transpilers to kind of go between dialects, but yeah, right now just SQLite.
Okay, Jimmy here is asking, wondering if they're able to get the matching table schemas that SQL queries were based on.
Yeah. So this data, especially the instruction one, does have all the schemas there. It's you really don't want to do text to SQL without. I mean, you can. It just doesn't give you anything that's that useful. So yeah, all the schemas are here, which is make getting data even harder. Yeah.
We got one from Dolev. Is there a similar model that is trained to only answer in JSON?
Yes. No, well, not from us. There are some academic works that have done text to JSON, or at least text to some of them even use proprietary models. Like there's a whole open source product called Guardrails, which helps you like get your output to always look like JSON, is one of the many things that it does. So there is some work in that space. Yeah.
We got another one here from Louis. To be able to use NSQL Llama in a company, you need to have self-explanatory column names, right? And as the prompt is the table structure, what would you suggest if the columns are not self-explanatory?
Yeah, that's a great question. So a couple things that you can do there. The two big ones are trying to get any there are ways that you can actually go and like get a fairly good semantic description of a column. Like sometimes you can even literally go have a model rename a column for you, so you have like a translation layer. If you give it examples of the column itself, oftentimes the model can be like, oh, this is an identifier, or this is a specific type of variable. So I'd probably look into that space, either describing the column or kind of again having some kind of model friendly translation. The other thing is just simply using in context examples, showing past questions issued over this table can oftentimes be really helpful for teaching the model what to do. It'll see patterns between like, oh, when a user asks for, XYZ, this is the right column here. So a lot of stuff can be done within context as well to kind of further customize the model.
Cool. A couple more here. Am I correct in reading the slide that you trained on Spider queries as well as using Spider as the evaluation set? This is from Lucas.
So we had in the blog post we have an ablation that looks at so Spider itself so we had some models that were again so the one that we fully released, we trained over the Spider training set because the databases there are fully separated. We do it in the blog post, show an ablation training on no Spider at all. But for the open source model, we did train over Spider training because we just wanted the absolutely best model that we could. Yeah. So again, but take a look at the blog. We do have some solutions there.
I'm going to try to squeeze in a couple other ones. From Pravesh, most use cases involving queries like SQL or say Bash scripts would be deterministic. How at all something as stochastic as a large language model, not to mention the vagueness in questions, can be used for these? And Pravesh is mostly considering security issues.
I see. So like how to prevent sort of potentially even nefarious SQL queries. Yeah, so I will say I don't have a fixed answer besides there are a lot of guardrails that you have to put on the SQL query itself. So the model will spit out one, but you should oftentimes not actually let the user have completely open door access to that. Like there's validation that you can do on your end by like, simply be like, is it executable? Is it touching these sensitive columns? Things like that on the output. And you can even kind of re-ask the model to change things up if you think it's making a mistake. And also having really good auditing pipelines for users and data engineers. Like the goal here is not to replace engineering teams because these models, again, are noisy. It's more to help them do their job and allow business analysts to be more self-service. So there's a whole product that needs to be built out around these things to address these very questions. But those are all like, it's still, and sometimes it still hallucinates, like, as you said, it's not perfect and it won't be. And so it's really about how do you build a product that handles this noise.
I know we're running out of time, and up next is a musical break. So I'm going to take the liberty to just ask you one more quick question. Have you thought about this, or like, how do you think about almost like a single shot LLM query versus more of like an agentic framework, where perhaps an agent is able to first understand some aspect of the problem and then gradually plan various sub-nested queries? Is there a way in which you can sort of like build a more complex topology of querying the model?
Yeah, I think yes, but I think also a lot of it is actually not only does it help quality, and it's kind of, also interesting, but users oftentimes there's a limit to what they can express in a single question, right? You'll see queries and logs that are like 8 levels of nested with 5 different CTEs, and there's no way a user's going to ask that question one shot either. So actually, what you do really want to be building a kind of multi-step pipeline where you're either building the query in steps or like having intermediate checkpoints. But it's also really based on giving the user trust in what's going on and engaging with them so that in essence, what you want is the building blocks to be single shot questions. So yes, like you have to get there. That kind of, I don't know if I'd call it like a fully automated, but like you need to be able to decompose stuff, because otherwise there's a whole slew of queries that like, I don't even know, unless I'm like writing an essay, I don't know how to even describe it in natural language. So that's another interesting thing that like for the first time Texas SQL is actually running up against, which is like, what's the limit of what a user can ask in a question? Because like before, models weren't even good enough to even really get there, and that's where we're starting to see this happen now, where you have to post it and break it down.
Laurel, we have thousands of people at the conference today, and I'm seeing raving reviews about this talk. So thank you very much for joining us.
Great, thank you.